next is PCM Waveform Types. See, when a pulse code modulation is applied, the resulting will be a series of binary numbers, either as a 0 or 1 after encoding the message, after encoding the real message signal. So this binary symbol, according to it is, we have to represent it as a waveform. Depending on the application, we have to choose the PCM waveform accordingly. For example, if you are going for telephony applications, these waveforms are normally called the line codes. So depending on the application, there are different formats we can represent the PCM waveforms. So normally we will say as NRSZ. NRSZ means non-return to 0 or return to 0, RZ. So non-return to 0 waveform or return to 0. Similarly, unipolar or bipolar. See, we'll see the difference. Non-return to 0 means your waveform will return back to 0 at any instant of time. There is a 1 or a 0, both you will represent, but the signal will not come back to 0 before the interval range. That is called a return to 0. I just tell you in clearly that. And unipolar and bipolar is, unipolar means high, 1 is represented by a plus voltage, 0 is represented by 0. This is unipolar, only one polarity. Bipolar means 1 is represented by a high polarity plus V, 0 is represented by a low voltage minus V. 0 is, the reference 0 will be different. Now we'll see about each wave. I'll tell you how to draw each waveform. Suppose you have given a sequence to enter is 1 0 1 1 0 0, this sequence. Now we have to represent it in NRZ format. So NRZ format means it is non-return to 0. NRZ means non-return to 0. Now how you can draw that? So here you have to represent 1 0 1 1. Same only I repeat, I just wrote 5 only. So listen, when it is a 1, we will transmit a high voltage. When it is 0, we are going to transmit a low voltage minus V. So now represented by 1 is represented by voltage level plus V, 0 is represented by minus. So first is 1, so it is represented by high plus V. Next is 0, so it should be represented by minus V. Again is 1, it is plus V, 1 plus V, 0 minus V. Now if we are checking here, this is the interval. Till the end of this interval, first bit interval, this is not coming back to 0. Till the end of this first interval, the 1 is not returned back to 0. That is the reason it is called a non-return to 0. That means, suppose in between it is coming back to 0, it is not non-return to 0. So, till the end of the interval, it is not coming back to 0. That is called, it is non-return to 0. So, a 1 is represented by plus V, a 0 is represented by minus V. So, it is a bipolar also. It is a bipolar non-return to 0. Now, we will see what is a unipolar return to 0. Now, next is return to 0. We will see that. So, here again I represent the same symbols 1 0 1 1 0. That same sequence I am transmitting. So, now it is unipolar. So, we don't need minus V. We need only one polarity here. So, a 1, this is a 1 is represented by plus voltage. Now, just see, it is return to 0. Return to 0 means before the end of the interval, the signal should have to come back to 0. It should have to come back to 0. So before the end of the interval, it could be any point. before the end of the interval, the signal should come back to 0. Now 0 is represented by 0 because it is unipolar. 0 is represented by 0. 1 is again represented by 1, and before the end of the interval it should come back to 0. Again a 1 is represented by 1. So before the end of that bit duration it should come back to 0. A 0 is represented by 0. So this is called a unipolar return to 0. Next we will see what's a bipolar return to 0. A bipolar return to 0. Bipolar return to 0, a 1 is represented by a plus voltage and it is returned to 0, so half of the bit it will return back to 0. And 0 is represented by minus voltage and it will return back to 0. So this is 0, it will return back to 0. Half of the interval it is in minus V, and then because here 0 is represented by a minus voltage. That is the only difference. It is unipolar and this is bipolar. Again a 1 is represented by a plus V, and after the half bit interval it will come back to 0. So a unipolar, this unipolar return to 0 case, half of the bit interval it is unipolar, so only 1 is represented by plus V. So in unipolar return to 0, 1 is represented by a half bit wide pulse and a 0 with the absence of a pulse. So 1 is represented by a half bit wide pulse, 0 with the absence of pulse. Bipolar return to 0 is represented by a 1 is represented by a half bit pulse with the plus V voltage level, and a 0 is represented by a half bit pulse with the voltage level of minus V. So that is bipolar return to 0. So in the bipolar return to 0, the 1s and 0s are represented by opposite level pulse with a half bit wide. Now next is return to 0 AMI. AMI stands for alternate mark inversion. AMI stands for alternate mark inversion. This is alternate mark inversion. Alternate mark inversion. So alternate mark inversion means a 1 is represented by plus voltage. A 1 is represented by plus voltage, and see it is returned to 0. So it should have to come back to 0 before the end of the time interval. And so 1s are represented by equal amplitude of alternate pulse here. So in return to 0 AMI alternate mark inversion, a 1 is represented, this is a 1. A 1 is represented by again a half bit with pulse, but it should come back to 0. It is returned to 0. It is returned to 0. Come back to 0 before the end of the bit interval. And zeros are represented by absence of pulse. Next one is represented by opposite polarity. Why? Because it is alternate mark inversion. So all the ones are represented by a pulse of opposite polarity. Now see, this is a 1, it is represented plus V, and 0 is by 0. Next one is represented by minus V. Next one is represented by plus V. Next 0, then this will be 0, 0, 0, and next will be represented by minus because this is plus. So it is alternate mark inversion. Alternate one will be of opposite polarity. Alternate one will be of, this is positive, then this will be negative. This is positive, this is negative. Like alternate one will be opposite polarity, and zeros are represented by the absence of a pulse. This is called a alternate mark inversion. Next is biphase L. This is biphase L. It is also called a Manchester coding. This another name is Manchester coding. It is another name is Manchester coding. Now here F1 is represented by a half bit width pulse starting at the beginning, and a 0 is represented by a half bit width pulse during the second half. So this is during the first half of the interval, this is during the second half of the interval. So F1 is represented by a half bit width pulse during the first half of the interval, and it is bi means biphase. That bi means you have two levels, plus and minus. So half 1 is represented by a first pulse which is in the first half interval, and 0 is represented by a pulse, half bit pulse in the second half interval. So just see, always a 1 will start from plus V and it will go to minus V in the first half. A 0 means it will start from minus V, it will start from minus V and then it will go to the plus. So now here see, it start from plus V to minus, that means it is 1. It start from again plus, this is start from plus, because again this is 1, why? First half interval it is there. So start from plus and going to minus, first half 1. This is 0 because it starts at a second half only. This is again 0, it start at second half only. This is again 0, this is 1, this is 1, this is 0 and this is 1. That is called a biphase level or Manchester coding. Now the next one is delay modulation. The last PCM type waveform shown over here is delay modulation. Delay modulation is also called Miller coding. It is also called, another name is Miller coding. Here F1 is represented by a after the half of the bit duration it will change in state. So F1 is represented by a transition at the midpoint of the bit interval, and a 0 means there is no transition. Again F1 means at the midpoint it is changing. This is again 1, at the midpoint it is changing. 0, no transition. But if continuous zeros are coming, alternate zeros are represented by a change in level. Alternate zeros are represented by change in level. So here F1 is represented by a transition at the midpoint of the bit interval, and a 0 is represented by no transition unless it is accompanied by another 0, unless it is accompanied by followed by other 0. So just see here I represent F1, so whatever be the level it will continue till here, and from the midpoint it is changed. Now this is 1, 0 means there is no change, and see here it is 1 because at the midpoint, next this same state will continue till the midpoint of then the state will change. Again F1, the same state will continue till the midpoint of this bit interval, again it will change. This is a 0, no change. This is again 0 because continuous 0 means it is alternately it will change. It is not at the middle of bit point, at the end of the bit interval, 0. Now again F1, the state will continue till the middle point, then it will change. It will continue till the middle point, then it will change. So this is called a delay modulation.